In an isosceles triangle, there are at least two congruent sides. Those two congruent sides are called the legs of the isosceles triangle. The third side, that is not the two congruent sides, is called the base. The angles. The angle between the two legs is the vertex angle. The vertex angle is the angle that will tell you what kind of isosceles triangle you have. If the vertex angle is acute, we have an acute triangle. If the vertex angle is obtuse, we have an obtuse triangle. And if the vertex angle is right, we have a right triangle. The two other angles that aren't the vertex angle, that aren't between the two legs, are called the base angles. Now the base angles theorem tells us that if we have an isosceles triangle, then the two base angles will be congruent. And the way we find out that the base angles are congruent is we go across the triangle. So if we have an isosceles triangle, then the two base angles are congruent. If we have the converse of that theorem, if we start with our base angles being congruent, then we can conclude that we have an isosceles triangle. The sides opposite those two angles are congruent. So we're going to go across the triangle, and since these two angles are the same, the two sides will be the same. Let's apply the base angles theorem. To solve for x and y, we can see that we have two congruent sides, which means that the angles opposite those two congruent sides will also be congruent. So that means that x has to be congruent to 35 degrees. Now to solve for y, in a triangle, all three angles have to sum to 180 degrees. So to figure out y, I'm going to take 180, and I'm going to subtract the 35 degrees here, and then I'm going to subtract the 35 degrees here. And that will tell me how big y is. And I can always double check my answer by taking 110 plus 35 plus 35 and getting 180 degrees. In example number 2, again we have congruent sides, which tells us that these two angles will be congruent to each other. But this time we know the vertex angle, and the vertex angle is 35 degrees. And we know that these two base angles will be congruent to each other. So whatever we get for x will be the same as y. Well, we have to do a little bit of problem solving here. Total in this triangle will have 180 degrees. So if I take 180 degrees and I subtract 35 degrees, that tells me that between these two angles, I have 145 degrees left. I need to split 145 degrees between these two angles. And in this case, since these angles are congruent to each other, I can take 145 degrees and divide by 2. And get 72.5. So x has to be 72.5 degrees, and y has to be 75.2 degrees. And the reason I know that I can divide by 2 is these two are the same, so I'm going to divide 145 degrees evenly between two angles. In a right triangle has to have a right angle. That's the definition of a right triangle. Now the side opposite that right angle is called the hypotenuse. The hypotenuse is spelled hypo, ten, use, and pronounced hypotenuse. The other two sides of the right triangle are called the legs. This leads us to another way to prove triangles congruent. In a right triangle, Well, if I have two right triangles, I'm going to have two triangles with right angles. If the hypotenuse, the side opposite the right angle, is congruent to the hypotenuse of another triangle, and I have one pair of congruent legs, then that's enough to prove that these two triangles are congruent by the hypotenuse leg congruence theorem. So I have another way to prove triangles congruent, HL. And once my triangles are proved congruent, all of the corresponding parts will also be congruent. All of the angles and the sides that are corresponding will also be congruent after I've proved my triangles congruent. So let's look at some examples where we need to figure out which postulate to prove the triangles congruent. In this example, we have a pair of right angles, and the side is shared between these two triangles, so those two sides are congruent. And in this case, we have HL. So these two triangles are congruent to each other by HL, hypotenuse leg. Now in this second example, I have right angles also, and I have a pair of shared sides that are congruent, but I have another pair of congruent angles. So in this second example, even though I have right angles, that doesn't automatically mean that I have HL. In this case, I actually have angle, angle, side, angle, angle, side. So don't assume that if you see a right angle, it has to be hypotenuse leg. Look at example 3. We have a pair of congruent vertical right angles. And we have a pair of congruent sides here, and another pair of congruent sides here and here. But if you look at the sides that are congruent, they're not the hypotenuse and the leg. Instead, we just have regular old side, angle, side. Again, don't assume that if you have a right angle, it's going to be HL. It might be, but it doesn't have to be. In example 4, we have the sides opposite the congruent angles. We have another pair of congruent sides, but we have just regular old congruent angles. So we really have side, side, angle, side, side, angle. And we don't have a side, side, angle postulate. So in example number 4, the triangles might be congruent, but there's not enough information. If we had some other piece of information, we could prove the triangle's congruent, but with what we're given, we don't necessarily have congruent triangles. Number 5. This segment is perpendicular to this segment, so we have a right angle, which means we have a second right angle. And we have a pair of congruent angles and a pair of shared sides. So in this example, we have angle, angle, side, angle, angle, side. And in the last example, again we have a right angle, which means that these two segments are perpendicular, so we have another right angle here. And we have a shared side. And in this example, we do have hypotenuse leg. So these triangles are congruent to each other by HL.